everyone, Aurora here with Supercharged Science, and today we are going to be doing a special chemistry class just in filtration. Now we have a lot of goodies we're going to go through here, and I'm going to show you how you can transform your dad's coffee back into water. So if you like this and you want more, you can download, or you can actually go to my website, www.superchargedscience.com/school, to learn how you can do this and thousands of more different hands-on science experiments. So while people are getting ready for and jumping on, because we are on Facebook Live, people tend to jump on and off all the time. So we are at the top of the hour. This is the 5th class this week, just in chemistry. If you missed any of them, you can go to my website, on the main Facebook website, and then click on videos on the left, and Facebook automatically archives all of our science classes that we've been doing, and so you'll be able to participate in all of those classes. Now the one yesterday you actually had to register for because it was such a big class. We had over 4,400 people, so 4,400 people registered for that one, so it was a huge class, and so we did that elsewhere. If you missed that one, you can go to my website and you can actually still sign up for that one, and you'll go instantly to the replay. So the reason I'm suggesting that you should watch these classes is because tomorrow we're playing a game. We are going to be doing a chemistry scavenger hunt, and you'll want to be able, in order to participate, honestly, you can participate just by showing up, but if you've watched the classes, your chances are much higher at winning the game, and I have prizes for everyone. So that's tomorrow at 10 a.m. Pacific, so it's Saturday at 10 a.m. Play a chemistry scavenger hunt with me. This is a great review to see how much you've picked up during the week, and if you've missed any of the classes, make sure you get those in today. Again, you can, Facebook will automatically archive those in the videos. You can also go to my website to watch that one that you might have missed yesterday. Just register for it. Okay, so what are we doing today? We are going to take some icky, gross water, pretty disgusting, and we are going to transform it back into something clear that you might actually consider drinking after you do some tests on it. And we're just going to use chemistry in order to do this. So if you know anybody who's interested in chemistry and likes the idea of chemistry and mixing up chemicals, invite them into this class right now and we will get started. Let me outline a couple of the materials, because some of the materials were a little strange. Maybe you don't have them, but you don't realize you have them, and you actually do have them. So let me go through that. So if you've been eating popsicles, save the popsicle sticks. These make little great stirs, but anything you've got is fine. And then I'm going to use clear cups so you can see what's happening. And I've got 2 different sizes here. Now, if you have a straw, have you ever done that trick where you put the straw in a liquid, in like a glass of water, and then you cover the end and you lift it up, and then if you lift your thumb up, like the stuff comes out? So that can be your pipette. You don't need like a fancy medicine dropper, although these are fun, but you just need like a straw, and that will help you transfer the liquids because you're only doing a small bit at a time. You're also going to need some sand, so this is from the backyard. And let's see, you'll need some water bottles. One of them needs to be empty. We're going to turn this into a filter so you don't have to have a funnel. And just regular water bottles. If you have a cheesecloth or a strainer, that will work too. And then if you were able to find pickling lime, this is great. If you don't, it's okay. It's an optional step. It basically will help with the calcium and the magnesium that's in the water that tends to make water really hard. So it'll soften the water for you, make it easier to filter. It's not essential though. It also adjusts the pH kind of near the end. We'll talk about that. And if you have activated carbon, this is the strange one. So if you have like, maybe you've got a fish tank, so the carbon filters are in there. Carbon is used everywhere. If you have like a barbecue though, and you've got charcoal briquettes, you can use those, smash them up small with a hammer. Don't do it right now, but you can smash them up pretty small, and it'll do a similar job for what we're doing. It's not as good as activated carbon. Activated carbon is like the charcoal briquettes, but have been treated with an extra step to help really grab the dirty stuff as the liquid solution goes by. But regular charcoal briquettes, make sure they don't have fuel on them already, like the matchlight briquettes. We don't want kids handling those because it's got fuel on it, and they actually will mess up your sample. So just make sure they're just regular carbon. There are a lot of other sources for carbon as well, and so, but this is, I haven't tried toner from an old ink, laser jet printer, but that's also a possibility. I haven't tried it, so I don't know if those fine particles are will work with this filter, but that's also a possibility. The other one is alum, which, whoops, I didn't get out. Okay, so I've got it down there. I'll reach it in a second. So alum is actually in the spice section. It's in baking powder, and it's also in deodorant. So if you have any of those things, just if it's in deodorant, just take like a little teeny piece and you're going to crumble it up and stick it in there. It might seem kind of funny, but that actually is the aluminum sulfate that you're going to need that will help coagulate things together. Okay, so that's the process we're going to be going through. You ready to get started? If you are, say, oh yeah. All right, and we have some people to say good morning to. We have Lauren and Natalie. Hello, good morning. And we have Naomi from Florida. Good morning. We have India. Hello, good morning. We have Daniel and Hannah from Washington. Hello, good morning. And I understand we also have Ellie and Andrew. Good morning. Good morning. Now, Ellie and Andrew actually are two of my kids. So if you guys can hear me, can you bring me the can of baking powder that's in the kitchen? And we will go ahead and get started with this class. You ready? Okay, so here we go. So the first thing we need to do is we're going to set at, well, here, let me move some things here so you can easily see it. So one of the, I have to say, I probably have the world record for emptying out an entire school all in one go for the shortest amount of time. So I'd been saving this sample in like a 2-liter soda bottle. And I'd been saving it for a long time, like maybe 9 months. I just kept adding stuff, and then we would use it in our filtration classes. And I'd add more stuff, and we use it in our filtration classes. And so eventually, there came a time where I didn't open it for like 3 or 4 months. And it was kind of sitting, rolling around in the back seat in the trunk. And I came to a school, and they had hired me to teach water filtration. And so we came, and I uncorked the bottle. It smelled so terrible. This water sample that I had of icky, gross water, that the classrooms next to us actually evacuated and went, whoa, all from a tiny little soda bottle. They couldn't believe how awful it smelled. And everybody in my class was like, yeah, we're good, we're doing science. And everybody else was like, what are you doing? So that's the kind of science we are going to be doing today. Okay, so here we go. So the first thing you're going to need is an icky sample of water. If you're going to use clear water, well, it's not going to work so well because it's already filtered. What did I put in here? Well, let's see. I had coffee this morning, so I had a little bit. And I put the grounds back in, and I put most of the coffee back here. Okay. We also have a fish tank. So I've got a sample of some water. Now, what do fish do in the water? Yeah, they eat, right? They swim around. What else do they do in the water? That's right. You can say it. It's based in science. Yep, that's right. So we have fish poop in here. Okay, so yum, right? All right, so we also have some of last night's dinner. You can add anything you want. A couple of things you don't want to add because they're too, the filter we're making isn't tuned for this type of thing. So if you have carrot juice, beet juice, any like fruit or vegetable juice, typically won't get filtered. So because you need a much finer filter. Okay, so you can stick whatever you want in there. Just get a sample of something, okay? We're not going to be drinking this. We're skipping step 5, which is bleach, disinfecting, because we don't do bleach around kids. But go ahead and do this right. Just go ahead and grab your sample. Step 1 of filtration is really super easy. It's like the easiest step on the planet. All you got to do is take a cup like this. See, cup right there? Here, let's move that. All right, and we call it aeration. This is why water filtration plants have huge ponds of this stuff. They are aerating it. What does that mean? It means we're pouring it into here. Oh, we didn't get the ick on the bottom. Let's put more in. There we go. Look at all that. Ugh, not even all the sludge came out here. Let's see if I can get some of the sludge too. There we go. I got more of it. Okay, great. So we have our sample. Now, what you also want to do is, I didn't actually leave enough room in here. Let's pour some of the cleaner stuff off. Okay, now I've got all the gross sludge. So I've aerated it. I've oxygenated it. I've allowed it to flow and allow oxygen to get around it. That's important because for our next step, we are also going to add a little more water. Okay, so we're going to dilute this a little bit. This is all part of aeration. So we're just allowing the air to flow around it so it doesn't become staggy and moldy and mildewy like when we cork it, right? We're allowing some airflow to happen. Okay, so we are gonna leave that there. And the next step is we're gonna add 2 ingredients. That's step 1. Step 2 is we are going to add, step 2 is coagulation. Coagulation means we're gonna clump things together and they're either gonna float to the top or sink to the bottom. Sometimes they kind of hover in the middle, but they're gonna be bigger particles. So right now, these particles are really fine if you were to take a microscope. It's hard to sift them out, right? If you think about it, if you've been cooking pasta, when the pasta timer dings, like ding, we're done, how do you get the pasta out of the water? Yeah, you have to put it through a strainer of some kind, right? So if we were to just pass this through a strainer, some of those particles are so small, they'll go through our strainer. The other thing is, if you think about it, how do we filter water in the first place? Well, we do it a couple of different ways. So if there's germs in here, for example, to use a very broad term, if there's bacteria or something in this sample, and you just add a bunch of chemicals to it, now we have a bunch of dead bacteria in the water. So we haven't removed anything. So it's important to add chemicals to glob things together so then we can filter them out, because we actually want to physically remove those bits in there that we don't want. Okay, so the second step is, where is my measuring spoon? My measuring spoon was right up here. It's probably up here somewhere. Okay, so the second thing we want to do is we want to open up our alum aluminum sulfate and our pickling lime. Okay, and so all we are going to do, there we go. Okay, and so I'm looking for my measuring spoon, which I don't see anywhere. Okay, I'm going to go grab one. Let's see if I didn't put it up here. Nope, don't have one. Oh, and I forgot to mention you're going to need cotton balls. Okay, so the next thing we're going to do is we're going to put a quarter teaspoon of pickling lime. Woo, here it goes. Okay, in there. And then we are also going to put a teaspoon. So we got a quarter teaspoon pickling lime and then a half teaspoon of either baking soda, about a half teaspoon of deodorant, a half teaspoon of something that has aluminum sulfate in it. So alum is in the spice section of your grocery store. You can do that as well. So go ahead and do that and then stir it around. Can you do that for a second? I'm gonna go find my alum because it disappeared. Hang on, stay right there. Okay, you guys ready? All right, here we go. Let me get my microphone back on. Nothing like a live show, huh? Okay, so I have some baking powder that I grabbed. And we're gonna open it up. We are gonna put a half teaspoon into our sample. Okay, so one of the questions I get a lot of is, what's the difference between baking soda and baking powder? That's actually a chemistry question. Oh, okay, and then we're gonna stir it around. Okay, and it's probably gonna change the color. Do you see how it's starting to change the color of the sample? So when you are a chemist, one of the things that you've got to do is hone your observational skills. That means you're gonna be watching for a change. Could be a temperature change, it could be color change, any change like that. You can actually start to see it's already, look at this. It's only been about 10 seconds. Do you see a change already? Yeah, it's clearer on top, really muddy on the bottom, and kind of neutral in the middle. Okay, so we are going to wait a few minutes for that to take place. We were just talking about the difference between baking powder and baking soda. So baking soda is the one that will react when you put vinegar with it, right? Okay, so baking powder is something that you would add. So baking powder is something that reacts to temperature. Baking soda is something that reacts with acid. So when you put both of them in your cookies, you have a much better, well, it depends on the kind of cookie, but you have a much better much better chance of them becoming light and fluffy. So you can't really substitute one for the other. It depends on what other ingredients you already have in your baking that you're doing. Okay, so this is step one. Wow, look at this. Look at the changes we're already seeing. Look at that. Do you see that? So this is step two, sedimentation. Step two is really easy. You're just waiting. That's it. So we also, what else is happening is the floc, F-L-O-C, is heading to the bottom, or it can float on the top. Depending on what is in your sample, it will either become so light as it gets larger that it'll float, or usually what happens is it gets so large that it sinks to the bottom, and that's not what we're gonna pull our sample from. This is gonna help us filter this out. Isn't that cool? Okay, so while we're waiting for our sample here to finish its sedimentation stage, you can actually see it's really striated, isn't it? Okay, so while we're waiting, we're going to build a filter. So the first step is to get a water bottle here, and you're going to put your crushed up carbon. Now again, this can be the carbon from a fish tank, this can be just any carbon source that you have. Oh, here's my teaspoon. Okay, and all you're gonna do is you're gonna put it in here a scoop at a time. If you're really impatient, you're gonna just make a funnel out of a sheet of paper and get a friend to help you, but this tends to make it go everywhere. You can make a little funnel like this, put it over here, and then have a friend just pour this in. So how much do you put in? That's a good question. This is what we're going for. Do you see how it made my water a different color? So we're going for dark. The darker, the better. And up to a point, no matter how much carbon you put in, it's not gonna make a difference. I probably put in about that much carbon. You can see some of it's floating, some of it's sinking. Isn't that strange? Okay. All right, so we wanna make some carbonated water, some black water, okay? So carbonated, did I say carbonated? Sorry, we want to make some carbon water. Carbonated is very different. That's when you have bubbles of carbon dioxide. Okay, great. So go ahead and put it in there. Now, by the way, I'm Aurora with Supercharged Science. If you've just joined us, we are filtering really icky water and turning it back into clear water using regular household things and learning what the different steps are and stages are of water filtration using chemistry. So if you like this and you want more, there's a website here that will show you how to do this. This is just one of the 2,500 science experiments you can do right from home. Okay, so the next step is to take an empty water bottle and turn it into a funnel. Now, how do we do that? I'm gonna first take the label off. Okay, so watch me first. So kids, this is going to be hard, so get a grown-up to help you with this one, especially if your water bottle is hard. It's going to be easy to slip because this is round. What you're going to do is you're going to cut the water bottle in half, just like that, okay? So here's the bottom half, here's the top half. We now have a filter. Well, we now have a funnel, see? Okay, so we are going to work on this part. You see that? Okay, so what do? So we are going to take some cotton balls, you got this? Fluff. We are going to fluff them and fluff them. And while you're fluffing, I'm going to tell you a really funny story that's true. So I teach live science, and do this for all 4 cotton balls, and then put them in the bottom. Okay, so while I'm teaching science camp one time, there's like, I don't know, 100, 200 kids there. We rent out a couple of campsites, and that includes like a big play yard and stuff, because we're messy. Things are wet, messy, on fire. We're loud. We launch rockets. We do tons of stuff. So we get to this part of chemistry. Here, keep fluffing while I'm talking. And a kid gets it in his head that, hey, well, that was dirty water. And I had just said, it was just at the end of a chemistry class, and we were about to take a break for a snack for like 10 minutes, and we're gonna come back and do more chemistry. So I sent everybody to go wash their hands, right, get all the ick that we were just dealing with the chemicals, and so they could have their snacks. So 200 kids are trying to use like 6 of the sinks with the water faucets. And this one kid decides, you know what, I'm not waiting in line. He plunges his hands into the toilet, and he starts washing. Here, fluff while you're doing this. And I didn't know this, right, because I'm over there prepping, getting ready for the next class. And so, of course, what happens? You know, the first ones that are done, so-and-so washed his hands in that toilet. And I'm thinking, oh, no. And he's about to eat, right? Can't you just see, the parents getting mad at me for this? I'm like, oh, no, what do we do? And so I thought, well, hang on a minute. we can actually use this as a lesson. And so we had just done water filtration, and he was like, well, the toilet water looked a lot cleaner than the water you brought, so I thought it was fine. So we had a conversation. We also didn't allow any of the kids to eat yet. I said, you know what, let's all do one more experiment. Do you have time for one more before your snack? And of course they're like, yes, of course, we can eat anytime, no problem. So I actually used an experiment where and I taught this to you a few days ago, where one of the ingredients was alcohol, like rubbing alcohol, ethyl alcohol, which is a disinfectant, and they got it all over their hands, which is exactly, so I disinfected all 200 of them. They wound up making bouncy balls using rubbing alcohol and one other ingredient, and they had a great time. And I was rest assured that the entire camp was totally disinfected. So, all right, so you never know what angle people might take, so you want to be very specific in your instructions. Okay, so here we go. So you've fluffed out 4 cotton balls. You've stuck them in there. All right, what do you do now? Now we're going to make the cotton balls as black as we can, because this is part of the filter. And we basically want carbon cotton balls in there. So I'm going to put it back over here, and all I'm going to do is uncork this. Now I don't want the little rocks to wind up in here, so you can use a cheesecloth or a strainer or something, and just kind of set it over, and then go ahead and pour that dirty water right on over. Now the cotton balls are going to shrink, as you can see. Okay, they're going to get a little more packed in there, which is fine. Okay, and you want to empty as much of that dirty cotton water as you can. Okay, and then you can put it over another cup and run the water back through, just to really make sure. And you'll notice that the water's coming out clear, and all the black stuff is getting caught by the cotton. Here, we'll put more on. You can empty the whole, oh no, I put the rocks in. Okay, so if this happens, I'm sorry, I was thinking about the kid with the toilet. Okay, so if this happens, no problem. All you're going to do, by the way, is science work right the first time, every single time? Of course not. That's why there's a second time and a third time. And it especially doesn't work right in front of large groups of people. Okay, so here we go. We'll just do it again. You just empty it out. It's not a big deal. And then I'm going to grab 4 more cotton balls, and I will do this again. You want another story? Boy, I have got stories like you would not believe. That's what happens when you teach for quite some time. Here, I'll actually do this one faster. And you can put 2 to maybe 5 cotton balls in here, depending on how big your funnel is. Okay, there we go. Don't try to dig out, unless you only have a couple rocks in there, I wouldn't bother trying to dig them out, because what they'll wind up doing is clogging your filter, so you don't want them in there. By the way, if you've done any classes with me, you know that it's really important to, oh, here, now we need more water in here, don't we? Okay, so you know it's really important to show kids what to do, not only when things go right, but also when things go wrong. Because a lot of books and textbooks out there, they'll start, here, this is the water from the carbon before, they'll start you off and say, hey, you should do experiment 1, 2, 3, 4, 5, and expect this to happen. But it doesn't have any troubleshooting information in there. It doesn't have any information like, hey, what do you do if it doesn't work out, right? So it's important to show kids really what it looks like when things don't go wrong, because that's life. That's what happens. Okay, so let me put this back in here. Let me empty this out. And we'll sit back down. Okay, so here's where we were. And we have carbon water, and we are just going to pour it over the cotton balls, just like that. Okay. And we want to get the cotton as black as we can. So if you feel like, hey, I think I want my cotton can be blacker than that, go ahead and put the water back in and do it again. Okay? Just like that. Okay, and catch all the rocks. Okay? Just like that. Okay, so the blacker the cotton is, the better it's going to work. Okay, and if you're really, really concerned, you can actually put more of the original carbon in your cup, just a little bit more. Add some more water, just like that. So we have super black water. And we are just going to blacken that cotton. Okay, you can swirl it around a little bit. Okay, and then we will just pour this in. There we go. That's looking really nice and black. Okay, just like that. And we'll give it a minute. All right, so while this is draining, and by the way, we're not going to be using this carbon water anymore, so you can just set it aside. Okay, so let's take a look at this. What do you notice? Tell me out loud. Does it look anything like when we started? Not at all, right? What's going on? So we have sedimentation happening. So this is what happens when we added the alum and the sodium hydroxide, right? The calcium hydroxide. When we added the pickling lime and the deodorant, basically, or the baking soda. Okay, so we've made our filter. We made one level of our filter. The second layer is really easy. You're just going to take some clean sand and pour it on top. Okay, so go ahead and just put some clean sand on top. Nice big clean layer. Okay, and you don't need much. Okay, just like that. Okay, so I have the cotton on the bottom, sand on top. Okay, and now we'll hold it here. The next step is pretty easy. We're going to get everything wet, and we're just going to do a teeny bit at a time. So if you have a cup of water, for example, like this, and you have a straw, you can put your straw in, cover the top, and put it through. Put your straw in, cover it up, and just put little teeny bits of water. You don't want to flood your filter, okay, because we want to save the filter mostly for the dirty water. But you just kind of want to get all the little pathways that this dirty water is going to take, kind of get them started. Okay, kind of priming our filter, okay? And then we're just about ready to go. You ready? Okay. So for those of you who have just joined us, my name is Aurora with Supercharged Science, and we are filtering water using stuff you can find around the house. Question, can we drink this water when we're done? Answer, no, because we are skipping the last step, which is bleaching, because we don't want to do bleach around kids. Okay. All right, so here we go. Let me put everything closer to you so you can see. Here's our cotton. Okay, so we've made our filter. We have the cotton on the bottom, sand on the top. I've got my dirty sample here. Let me show you where we're going to take our sample from. So with your straw, with your pipette, with medicine dropper, whatever you're using, what we're going to do is we are going to pipe in some from this clear layer. Now, depending on what was in your sample, you may have a cloudy layer on top. If you are, don't pipe from that layer. Get your straw in there from this layer, and then that will fill it up. Now, you're going to have to put your straw in quite a bit in order to get that much of a sample. So I'm going to take it not from the bits on the bottom, not from the bits at the top, but the bits in the middle. And I will bring this closer to you, so you tell me. Here we go. It's clear, isn't it? Well, let's put more in. So you can keep doing this over and over and over. Oh, thank you. Yeah. I have my helper give me some straws here. So you can keep doing this, and you will get water that comes out. Isn't that cool? Okay, wait, we're not done yet. There's a few more steps. So that's step number 4. So what have we got? The first stage was aeration. We poured it in, right? Then we added a little bit of water. Second stage, sedimentation, coagulation. We put the alum, we put the lime in, stirred it up, let it sit. It did the third stage, the second stage, sedimentation by itself. The third stage is where we started making a filter, and so while it's sedimenting out, right? And then the next stage you would do is you would actually test the pH and adjust the pH, as well as you'd add a few drops of bleach. Now, again, don't do this at home. We don't want bleach and kids mixing at all, ever. So we're not going to drink the water that comes out of here because we're still missing the disinfectant stage. Now, there's a couple of extra things you can do. One of them involves a glow stick. Now, notice I've got gloves on when I'm doing this experiment. I'm not touching the bits that are in here, but I can break this, shake it open, or shake it, and it starts to glow. I don't know if you can see that with the studio lights on. And now, under a new light, in a new cup, at a grown-up, because these are going to be hard, is going to cut off the top. Now, why would you be doing that? Because now I've got a sample, I've got a dye that fluoresces. Why is that important? Because I can add it to my sample, and you can grab this radioactivity, this radioactive bits out of the sample and see if it gets stuck and where it gets stuck in your filter because it's glowing. So you can add this in here. You'll notice that there's a few places that it's resting right now. I don't know if you can see this. There's blobs here in this layer, which tells us it's heavier than this flock. But there's also some near the surface up here. So I can grab the ones near the surface and pipe them through. When you're done with your filter, get a folded up paper towel, invert this filter, take the funnel part off, and then you can use some toothpicks or you can use your popsicle sticks and dissect the filter and see where different things got stuck. So what do you think? Is that cool? So there you have it. You have basic filtration experiments for kids. What can you filter in your house? Lots of things. So if you have dirty, icky water somewhere, the dog dish you haven't cleaned up, maybe you've got, honestly, just putting the grounds back in coffee and running this through works really well too. If you have some fish water, you can throw that in there. But again, are we drinking this stuff? No, because we didn't do the disinfectation stage. And honestly, this is a homemade filter, not exactly for human consumption. This is more of a demonstration piece. Okay, so if you like this and you want more, you want to go to my website, www.superchargedscience.com/school. There's a website right there. And you will see there's all information where you can get an additional 2,500 experiments, activities, projects for your kids to do real hands-on science just like this. Kids, when you're doing this experiment at home, I've given you lots of different substitutions. This would make an outstanding science fair project if you were to try different types of samples with your filter, or the same sample but different things in your filter. Maybe you use different kinds of sand, maybe you use gravel, maybe you use different types of dirt, maybe you tried different types of carbon, maybe you tried the briquettes, the toner from a laser printer, and you tried, ground up like pencil shavings, because that's also graphite. There's a lot of different ways you could vary this, just varying one variable that would make an awesome science fair project. So I hope this has been helpful. If you're playing the scavenger hunt with me tomorrow, it's at 10 a.m. Here at Facebook Live. It's free. You don't have to register. And if you haven't watched all the videos from this week, make sure you do that before the scavenger hunt so we can really get the most out of our time together. I will have prizes for everyone as well. So go ahead and check out superchargedscience.com/school if your kids have really been enjoying and learning a lot from our hands-on experiments we've been doing for the past 3 weeks. Next week, we will be diving into biology, and we are really excited to bring that to you. So if you've done the marine biology class, we are going to take an even deeper dive into the entire field of biology and kind of look and do some experiments that typically are either reserved for high school or college, but we can bring them down into, so kids that are about 6 or 7 all the way up to 14 can enjoy those same experiments. Things like measuring the rate of photosynthesis, measuring the size of a molecule, taking a look at pond water samples in live cell microscopes you can make right at home. Super easy stuff, super fun to do. And we will even do some, I think we're doing some experiments with DNA as well. A lot of people jump straight to that experiment, and then the kids are like, okay, don't know what that is, don't know what it means. So we're going to take it step by step so you not only do the cool experiments, but you really understand what's going on. So let me see if there's any questions that came through. I'm sorry, I forgot to do this. Sometimes reloading helps me. Did the videos can be, if you're having problems with the videos, all of the Facebook Live videos are archived automatically by Facebook in videos. So just look on the left side and click videos and you'll be able to find those. Let's see. If the video froze on you, I'm so sorry. That's an internet thing. Everything looked okay here, but maybe there's a slow internet. Sometimes that happens. And earth science, we actually are planning to do some geology as well. We just haven't scheduled it out yet. We have geology, magnetism, thermodynamics, and what's the other one? Electricity and robotics that are coming as well. But next week, the most requested was biology, so that's the one that we're going to do. Okay, 10 a.m., which time zone? Okay, so that's going to be Pacific time zone. So same time that all these classes have been at, 10 a.m. Pacific. Tomorrow is the scavenger hunt that we're going to have a fun time just playing and learning together. Okay. If you do have any other questions, do let me know. I'm Aurora at Supercharged Science. And if you like this and you want more, share it with your friends so they can also access more science materials that are out there where kids can really learn more science than maybe they have normally in a regular classroom environment. So I'm excited to be bringing this to you. I will see you guys next time. Take care, everybody.